In this video, we demonstrate the fundamental display operations on STM32. The goal of this demonstration is to show how basic display-related parameters can be modified and verified using a ready-to-run LVGL project, without changing low-level drivers or hardware connections. We begin by importing a project matching our display from the Riverdi Git repository into STM32 Cube IDE. To open the project, all you need to do is open .project file, but to do that, you need to use IDE provided by ST. You can use other environment, but this example is based on the STM Cube. If everything is right, you will see the whole structure of the project on the left. After opening the project, we build it and program the firmware into our Riverdi STM display. Once the application starts, the LVGL demo is displayed correctly on the Riverdi screen and touch input is already fully functional. This confirms that the display, touch controller, and software stack are correctly initialized. The first operation we demonstrate is backlight brightness control. We need to open team.c file, which contains all the clock's configurations. We need to modify team15, which is a timer that corresponds to backlight. The pulse parameter is proportional to the intensity of the backlight. By default, the parameter is set to 998, which is maximum value of 100% backlight intensity. By lowering it to 98, we set the value to 10%. As soon as the application is updated, the display brightness is visibly reduced. At the same time, touch functionality remains fully operational. This clearly shows that adjusting the LCD backlight does not affect touch detection or touch accuracy. This behavior is universal across all Riverdi displays based on STM32, as the backlight control is independent from the touch interface. Next, we demonstrate screen rotation using LVGL. According to the documentation, we have to have partial rendering enabled in this project, which we do. Then, the display rotation is configured directly in the LVGL display settings. By using partial rendering and LVGL's built-in rotation support, the application logic remains unchanged, and hardware-specific complexity is hidden from the user. After rotating the screen by 90 degrees, the image is rendered correctly in the new orientation. No changes are required in the LCD driver or in the low-level display configuration. Most importantly, touch input remains correctly mapped to the rotated screen. Touch coordinates are automatically adjusted by LVGL, and user interaction works as expected without any additional calibration or manual coordinate transformation. We have shown how to adjust backlight brightness, rotate the display, and verify that touch input remains fully functional. These operations form the foundation for any graphical application built on STM32. Once these fundamentals are correctly configured, more advanced user interfaces and application features can be developed on top of a stable and predictable display system. Head over to our website to explore Riverdi products and check out more guides on our blog and YouTube channel.